this video, we're going to apply the rules of logarithms to certain problems. And the first problem we look at is apply the rules of logarithms to evaluate the following. 3 log base 3 of 27 minus log base 3 of 9. So we'll just take a look at that. The problem given was 3 log base 3 of 27 minus log base 3 of 9. So we can simply use the rules of powers and simplify. So that's the same as saying 3 log base 3. 27 is 3 cubed minus log base 3 of 3 squared. And then we can take these powers down. So that's the same as 3 times 3 is 9 log base 3 of 3 minus 2 times log base 3 of 3. And we know log base 3 of 3 is 1, so that equals 9 minus 2 equals 7. So there we have the first example, simplifying that log without having to use a calculator. Let's take a look at another example. And the next example is to use the rules of logarithms to evaluate the following. 3 log base 2 of 4 plus 4 log base 2 of 8 minus 2 log base 2 of 16. So we'll take a look at that example. It's quite similar to the last one. We'll just write it out here. We have 3 up to the top of the page. 3 log base 2 of 4 plus 4 log base 2 of 8 minus 2 log base 2 of 16. Now we can use a similar approach as I did in the last one. There's always two different ways of doing these problems, but I like to apply, when I see a relationship between what's inside the log and the base, I'll express everything in terms of the base. So that gives me 3 log base 2 of 2 squared plus 4 log base 2 of 2 cubed minus 2 log base 2 of 2 raised to the power of 4. So again, we can take this squared power down. 3 times 2 is 6. 6 log base 2 of 2 is just 6 plus 12. 4 times 3 log base 2 of 2 is 1 minus 4 twos are 8. Equals 10. So 10 is the final answer of the second problem. And we just really use the rules of powers in that case. We could have approached it using bringing the logs together using the multiplication or the subtraction rule equally. But let's look at a different kind of example now. Number 3 is a practical problem. So here we've got a bricklayer. It takes 10 minutes to build the first metre of a low wall, and with every subsequent metre he speeds up by a factor of 0.9. So his second metre takes 9 minutes, his third metre takes 8.1, and so on. How many metres will the bricklayer have completed after 1 hour? Okay, let's take a look. So this is in example 3. His first metre takes him 10 minutes. His second metre is 0.9. Sorry, it's not 0.9. His second metre takes him 9 minutes. 10 minutes, then 9 minutes, then 8.1, and so on. Now we notice it's by a factor of, he's speeding up by a factor of 0.9. So effectively we have a GP. And in this GP, the value of A is 10, and R, the common ratio, is 0.9. So what we're asked is how many many meters has he completed after 1 hour? 1 hour. Now we're looking at minutes, so what we'll do is we'll make that 60 minutes. So what we're looking at is Sn, and we know Sn is A, which is 10 on 1 minus r, which is 0.9, raised to the unknown value n, all over 1 minus r. Um, we'll set that equal to 60 and solve for n. So I'm going to just simplify Sn, bring it over here, Sn. So we've 10 divided by 1 minus 0.9, which actually simplifies down to 100. Equals 60. And I'm looking to solve the unknown in the power, but I'll keep simplifying until I'm left with 0.9 raised to the power of n on the left. So I'll divide out by the 100. So we're going to have 1 minus 0.9 n equals 60 divided by 100 is 0.6, and I'm going to have on the left negative 0.9 raised to the power of n equals 0.6 minus 1. So I'm going to have two negatives, so negative on the left, 0.9 raised to the power of n equals negative 0.4. So I will need to make both sides positive and use ln. So I have 0.9 on the left equals 0.4 on the right. Taking ln of both sides, 0.9 to the power of n, ln 0.4, and n therefore equals ln 0.4 all divided by ln 0.9. And I'll pull up the calculator for this calculation. So we're looking at ln 0.4, close the bracket, divided by ln 0.9, close bracket. We get 8.69 approximately equals 8.7. So we can say 8 meters are complete after 60 minutes. So that's it for the last example in this video. Thanks for watching.